Okay, in last lesson, we learned the assignment operators and the comparison operators. The assignment operators, except the first one, the rest are also called compound assignment operators. The compound means it's not just, they use the equal sign to assign. They do some computation, like a mathematical computation, addition, subtraction, multiplication, division, and a modulus, and then assign the value of that contribution computation to the variable. That's why it's sometimes called a compound assignment operators. Then we look at we learned the comparison operators, basically to compare two values or two variables, the equal to, not equal, greater than, less than, greater than or equal to, and less than or equal to. Let's review the quizzes. First one, what are the assignment operators? We just saw that is to assign values. The plus equal stands for the addition assignment variable. So it does the addition and then assign the result to the variable. So in this case, if x is 10, then x plus equal 5, that means add 5 to 10, and that's 15, and assign 15 to x. So the final value of x is 15. The next one is the modulus assignment. So if x is 10, then the modulus or the remainder of the division by 3 is a 1. So the final value of x is 1. And comparison operators are to compare two values. So if x is 10, this comparison is x equal to 11. No, so it returns a false. The next one, 10 not equal to 11, that's true, so we return true. And x less than 11, yes, so that also return true. So those are the answers. Do you have any questions on last lesson on assignment operators and comparison operators? If no, then let's continue. And for today, we are going to learn something new. One is the last group of operators, Java operators, is called logical operators. And then we start to look at the Java math class or math functions. First, let's start with the logical operators. There are three logical operators. The logical operators are used to determine the logic between variables or values. The first one is called the AND logical operator. And basically is to check two comparison of conditions of two statements. The result is true if both are true, otherwise it's false. If either one is false or both are false, then the result is false. So only both are true, then the result is true. That's the AND logical operator. Ampersand, ampersand. For example, if x is greater than 5 and less than 10, then the result is true. So if x is like, well, assume it's an integer, then like a 6, 7, 8, 9, all need that this check on condition. So that's how the AND operator works. The next one is OR, the two vertical bar, or we call it vertical bar or type sign, but anyway, so that's a special character. It's on the keyboard, I think it's above the backslash. The OR means if either one is true, then it's true. Like the first one is if both are true, then the result is true. This one is if only one of them is true, then it's true. If both true, that's still true. If one is false, it's okay, still true. So as long as one is true, then the result is true. That's all. So, for example, if x is greater than or equal to 10, or x less than or equal to 5, then it's true. Let's see which one. We can pick a number. Let's say, how about 9? 9 is not less or greater than 10, but however, 9 is less. Oh no, it's not less than 5 either. So that's not. So in this case, actually, you can see that not 9, right? So it has to be like beyond this 5 to 10 range. So not 9. How about 4? Yeah, 4 is okay. 4 is less than 5, so that's true. Of course, it's not greater than 10, but it's less than 5. As long as 1 is true, it's true. So yeah, 4 is okay, and anything less than 5 or anything greater than 10, or even 10, including 10 or 5. That's all. The third one is this exclamation symbol and all the band sign. It's not. Basically, it reverses the result. If the result is true, then not true, that's false. If the result is false, then reverse false, that's true. So it's just like it's a not. So if x greater than y is true, then not as false. If x greater than y is false, then not is true. It's just reverse it. Let's try some example here, actually. Let me add a file. Why don't we call it logical operators Java. Okay, I got that. And never forget that the next line, I just copy it. Let me just copy that line. Okay. Oh, of course, need a pair. Forget it. So let's pick a value. Let's say x is, it doesn't have to be integer. Why don't we use double? X equal to, let's say 99, 99. Double, to be safe, add a D at the end. And let's print out some value. Print out, let's say C. Oh no, system out, I think. Out. Nope, that's not how it works. I think the C out. System out, print with a line. Yeah, okay, we find X, good. Now we're not printing X. I'll say X greater than 80. And yeah, that's true. And X also greater than 90. And see what happens. We expect it to return true. Because X, yes, X 99.99 greater than 80 and greater than 90. So they should return true. Let's run it. I got something funny here. I cancel. The value of our rows is not missing. Double. Another compare with that. Oh, compare with, maybe that's why. Not the D. Try it again. The value of local variable is not used. Oh, it's not, wait. Oh. Always complaining about the other one. We don't care about that one. Oh. The class name. We don't need that. I don't know where that's from. They remember that the class has to be started with uppercase. I'll run it. Bill fail, do continue, cancel. Oh, I guess the first time use it is getting on the way. Let me just compare there. Here. Oh, did I save it? Save it. I haven't saved it. And run it here. The public type must be defined in its own file. Oh. Oh, I see. Here. Rename it. Can I rename the file? So the file name needs to match the class name. So that's why. Now it's better. So that's a good opportunity to review what we learned about the class name. The class name match the file name. Otherwise, get all the different kind of errors. Now let's run it. Okay, now it's happy. So it returned true as expected. Okay. Let's try a different thing. So that's true. So is X less than 80? Obviously no. So we should get a false. Yeah, it's a false. As long as one statement is false, then whole thing is false because it's AND operator. The next one is OR. Let's just copy that thing. Let's see. What is OR here? If we OR, okay, 99 not less than 80, so that's false. How about this one? 99 is greater than 90, so that's true. So since this is true, then the whole thing must be true because this is all. As long as one is true, then the whole thing is true. Let's try it now. Yeah, so it's true. As long as one is true, it's true. So if both false, then it's false. So let's say 99 less than 18 false, less than 90 false. So then nothing is true. So the result is false. You see. Yeah, so it's false. Okay. That's that. I should say false. False. So we try the different values. The last one is not. Let's see, let's copy that. And not, we don't need two, so not only one statement. And when we use not, you cannot do that. Because if you do that, it's not the X. And then compare a Boolean value with a double, then I guess we would either get an error or get a false. Let me see what we get. It's not doing anything here. It's not there. So it's not outputting anything. Let me add the parentheses here. You do need to, put that inside and then not the whole thing. Not work on anyway on the either true or false. See, this result is a false. 99 less than 80, that's false, and not false. So the result should be true. Yeah, so the result is true. That's how they, well, if it's true, then the result will be false. So I change that 99 greater than 80, that's true, and not true, so that's false. Now we'll get a 3 false, right? Okay, so this is false now. Okay, I leave that there. Oh, and of course, here, you print out the Boolean value directly, or actually you can save you can also save it. Save the result to a Boolean value. Let's say Boolean. Remember the type, the Boolean type. Boolean, let's say called a B, and the whole thing, and then we just print out the B. Then let's see if we get it. Why don't we add something? Boolean equal to something. Let's see. Put that into parentheses. See if that helps. Yeah. So if you want to save the logical value, logical operation value into a Boolean variable, you can, but remember to put them inside the parentheses. Then you can print out the Boolean value. So that's what you get here. Okay, so you can save there. Because sometimes, this looks messy. You can put it into a variable and then print the variable. That's how you do it. Okay, check the time. Okay, so far so good. Okay. Now here, good. The next thing is Java Math. Yeah, we learned the not assignment, the arithmetic operators, you know, those addition, those, yeah, those just mathematical operators. And the math here actually is not about those operators, it's about this math function. In Java, almost all the known math functions are implemented or created underneath a math class. So the math is a special class. It has many methods, or the computation methods I think you can think of. So it's very handy when you need to compute anything. You don't have to write your own code. You just call those functions, and so it's very useful. If you ever write Java program to do data analysis or statistics or functional computation, etc. We're going to just take a look at a few of them, and let's see how they are used. Don't worry about the class. We will learn about that in future lessons. Class is part of the object-oriented programming. It's different from so far we haven't really learned the concept yet, but you can see that this is a class. This is a class. In our example here, remember this is a class. So in Java, everything has to be wrapped inside class. Oh, here is a good example. This is a method. This is a function or method inside this class. So this function belongs to this class. If you ever need to call this method outside this class, you would use logic operator, apps.may, just like this math here. So this is a math class, and this is a method, and xy is just like here the arguments or parameters. Okay. Let's try an example here. Again, let's add. I just call it. This time I remember use uppercase and make sure it match the class name. Oh, I guess they see the math is reserved. This is a reserved keyword by Java, so we cannot use it anymore. Otherwise, we cause conflict. So we called, how about called math? I don't know, math examples maybe. Yeah, math examples. How about that? Here return. I got that. And add the public method may. And remember the string arguments. That's fine. Oh no, not that. Args arguments. I think there's something here. I think public static. Let me check. Yeah, static, because we don't make the static. Let me see, where's my math? Math examples. Yep. So add a static. Okay, that's our math example class and a method defined. Now let's call this thing. We call it numbers equal to, let's see, okay, just use that 50. And you can declare multiple variables on the same line. Y equal to 250. So we have two variables. Now let's do a math. Or we can save it. How about another variable? result. We just call the R here. You don't have to assign any value because we're going to use it to store the result. Let's see, R equal to mass. Mass dot. Oh yeah, see, if I type a mass, this editor load the Java library and list all the functions here. Basically, to say what do you want here? Okay, we want the X return. So it even give you, okay, if you call max the max function, then you need two parameters A and B. So in our case, we don't use A and B, we call X and Y. That's totally fine. As long as you enter two variables, that's fine. Okay. And here's semicolon. Oh, did I explain what a max does? Max is to find the bigger value or highest. Well, only two, so but just the bigger, higher value or highest, no, not more than two. So the higher value or larger value of the two variables. Then let's print out. Dot out dot line. Not print X, one print R. So we should, we can guess. Oh yeah, only two value. Which one is larger? Yeah, 250, of course. 250. Can guess it. Now let's print. Let me save it and let me run it. Oh yeah. So yeah, it's 250. Yep. You may say, oh yeah, you got a two value, I don't need to call the function, I know the result. But the point is, in programming, when you do a lot of math, in the complicated project, you may not know the values, you just give you two variables. So yeah, without seeing the value, it's really hard to compare. But that's a max. That's pretty straightforward. And another example is get the, of course, got the highest value. How about get the lowest value? Yeah, you can do the same thing. Let me delete that line, put those two together so we can repeat. How about mean value? The lower. The list of the thing. Oh, and by the way, you see that the mean int, mean double, flow, long. Yeah, this is something called method overloading. The same function in theory should not use the same function for different things, but in Java, depending on the parameter type, you can you can have a different it will call it different function actually. If you enter to int, it call this one. If you enter to double, it call the next one, and the result is also double. Yeah. So yeah, if the primary is int, the return time is int. If the parameters are double, then the result is double. Don't worry about that. We just keep in mind, we will learn that future, okay? So for now, we just enter to int, equals to int, and the result should be also int, R is int. So minimum, of course, smaller value in this case should be 150. And let's verify. Yep, so it's 150. So that's the mean function. And what's the other one? Let's do another one. We take the time, 32, fine. SQRT. Your math class, I believe you have learned the square root. Square root means, the square root value times square root value is the value, is that a value. For example, square root of 4, square root 4 should give you like 2, right? So it's 2. 2 times 2 is 4. So anyway, so there's square root function here. Now let's do this. Instead of save to R, I'm going to just print you can do this actually. You don't have to save the mass into a variable. Just like I need a mass square root. Oh, only double? That's interesting. See, require double. What if I don't give a double? I gave it just integer. We probably convert integer to double and then do the square root. So I don't know the result is 4 or 4.0. Let's see. Yeah, so it return as we type the square root, it's only one, this function only one flavor, just like take a double and then return double. So even though we gave 16, internally, I think it converts 16 to like something like that, and then do the square root thing. So that's that. And yeah, if you enter double directly, let's see what happened. What's another value? How about, I don't know, any number. Oh, that's 5. So let's put something like, it's not integer thing, like I got a decimal points, like a 24. What? Yeah, what's the square root value of 24? Let's see what happens. Or 24, give it a double. I don't know. 2450 double. See what we get. Oh yeah, it's definitely is a double. many decimal digits. All right, so I wouldn't even type that thing here. Oh, that's the square root. Oh, the other one, ABS, it stands for absolute. Or absolute, also that, that in math is means you get the positive value of a variable or value. If the value itself is negative, the return is positive. If the value is positive already, then it's still positive. So you always get the positive. That's called absolute value. Let's try one here. Delete ABS. Oh, the ABS take how many? Oh, actually, yeah, 3. Long double int float. So in this case, we give it whatever, either integer or double or long, doesn't matter. Give it a value like 100. We should get positive, 100 back. Let's see. Yeah, so get a positive, no negative. So it works with integer, also work with float, anything. Again, if it's positive already, then no matter. It's, then get the positive again. So it's 105. Now that's how the absolute works. This one is more interesting. Random. It's another mass function is random. Random will return a random number between 0, 0.0 and between 0 and 1. But I think it's also a double, it return double, just like a square root. So which is interesting about random is a return a value, between 0 and 1, but not including 1. You don't get a 1. You always get something, smaller than 1. But the 0 is included. You may get a 0. You get a 0.0 something, but you never get a 1.0. You never get a 1. Just keep in mind that. That's why I called, for 0 is inclusive, for 1 is exclusive or not inclusive. Okay. As examples, that's fine. We can put it into the same here. Let's copy. Adding here. I'll call it a random. Oh, see, only one. I think one type. It always return double. No other type. So random just return always. So the thing is every time you run it, and let me just get rid of that. Just too much. Every time you run it, it get a new value. Run it. So it's this one, 0.8, run again. Come on, run again. This one is 0.2, run again. Okay, so 119. Oh, it's 0.718. So this one in the I think a lottery draw. I think they almost like all the lottery draw, they use this kind of random function because every time you try to get a value, it's different. Every time it's different. But this is a basic value or basic use of random mass random. But in reality, you probably don't need a value between 0 and 1, right? If let's say you go to a party of 50 people, you hand out a ticket, from 1 to 50, you probably want to draw a value between 1 and 50, not 0 point something or not above 50. How to get a value, between 1 and 50? The way to do it is to do this. You scale up because we know it's between 0 and 1, so you scale up 50, right? And now let's run it. Oh, okay, you get a 25.16. Yeah, no one get a ticket, like a 25 point something. You probably only need the integer part. So to do that is remember the typecasting. So we only need the integer part. You get a 0. And let's see. Oh, still 0. You never get anything, more than 0. What happened is, you remember the math, the multiplication, division take a precedence, and then do the minus and plus minus. So in this case, the system doesn't know the int, which type, which one you want to do the type casting. So it just like assume we want to convert that as a double to int. And because the mass random always returns a value between 0 and 1, and then the int of it is always 0, always 0. So then since you always 0, and times 50, you still get a 0 all the time. And that's why, we got a 0, 0. So to really get the non-zero value, you have to call that. To basically convert the whole thing to integer. Now you get something different. Now you get a 13. Run again. Okay, that's 0, but that's fine because we know that 0 is inclusive, so it's okay. But we shouldn't get a 0 all the time. Okay, now it's 6. And we shouldn't get anything above 50. Now that 42. Then the question is, since we never get a 1, then we never be able to get a 50. So that's a problem, right? And remember, we got a 0 once. So again, if you go to a party, 50 people and hand a ticket, number 1 to number 50. So the 0 actually, we don't have a ticket of 0, and we need a ticket of 50. So to do that, it actually is to move up by 1, right? So scale up and then plus 1. So in that way, then we won't get a 0, and then we have the chance, to get a 50. We'll try that because it's really hard to test that, to hit the 50 and 0 unless you keep running a lot of time. But oh, okay, wow, look at that. We got 50. Pretty lucky after 3 draws, 3 tries. So this is how you scale up and then add 1 and then get rid of the 0. Okay, and so if they say, hey, we got 500 people, like during the New Year celebration, we draw the tickets based on family ID. We scale up like by 5,000. Because our family IDs go around this number. We run it. Let's see this is family ID. Okay, now this family ID 4862 win. And next one, okay, family ID 798 draw. So this is how we design this lottery based on the random number function. Let me check the time. 0:45. Okay, good. Yeah. I think we just finished everything. So scale up, 2000, scale up. Yeah. Right. Okay, so we did everything. That's pretty good. We did everything on time. And again, I give you some questions to think about. Based on the what we learned today, we learned logical operators, and then we learned some math functions. Oh, by the way, speaking the math functions, I think math. There are many math functions, and there's a online reference, and see this one. This lists all the math functions, and I'm going to save that. Into the our landing page, so you can, if you ever want to try anything else, we try the absolute value, or we haven't tried this, those values on the angles, or let's got trigonometric functions, cosine, sine, or exponential, flooring, logarithm, and max min we did. Oh, there's a power. This is interesting. Like 2 to 4, 2 to 2 is 4, 2 to 3 is 8. You just call POW. So I'm going to add a link to our reference to our page here at the bottom. That's something. Okay. Yeah. Think about those questions, and I will provide answer later or in that next lesson. Okay, I think that's it. It's 48 now. I think I'm going to start the share.